Okay, we're going to work with those greatest common factors of monomials a little bit more to give you guys a little extra practice and show you another video to help you out. So we'll start with the video. This one's going to be different than the Khan Academy video you watched at the end of yesterday's lesson.
Okay, in the second tutorial on GCF, we're going to look at how to find the greatest common factor of two monomials. So remember, a monomial is a combination of numbers and variables. So we're going to look at two different ways to do this. The first way is we will use our double division with the whole monomial, 24a cubed b squared and 32ab squared. So we'll pull out common factors. I'm going to focus on the numbers first, 24 and 32. I know 8 goes into both of those, leaving me with 3a cubed b squared and 4ab squared. Now I'm going to look at the variables in this case. So I'm going to look at the a's first. So I have a cubed on the left and just a on the right. I know a can be taken out, so I'm left with 3a squared b squared, and 4, the a's have been canceled out, b squared. Now I'll focus on the b's. I have b squared and b squared. Well, the common factor there is b squared. So I'm left with 3a squared and 4. So, just like in our previous example, these two numbers, or two monomials at the bottom, are relatively prime. And on the left, we have our common factors. If we multiply those together, we get a value for the GCF that equals 8ab squared. So this is one technique of doing this. The second technique is similar, except instead what we do is we focus on just the numbers first, 24 and 32. So once again, I'll just pull out that 8 really quickly since I know that already works. 3 and 4, relatively prime at the bottom, and GCF on the side. So I know that my GCF is equal to 8. To find the value of the variables that go here, what I'm going to do is I'm going to compare powers. So factors are smaller than the original number. So I'm going to look for the lowest power of A and the lowest power of B. So here I have A cubed, and here I have A with no exponent, so that's a 1. So 1 is smaller than 3, so 8A. And I'll do the same thing with the B's. I'll compare the powers. B squared and B squared are equal, so B squared is our lowest power of B. So a different technique for finding which variables, or what the power of the variables that goes into the GCF. So once again, two techniques for finding the value of the variables. Either you can divide them out using the double division method on the left, or you can compare powers and look for the lowest power for GCF on the right.
Okay, now we're going to try one more example, and we're going to kind of use that technique that he said. I'll show it two different ways as well. We will do putting them both side by side and pulling out common factors. And 42x y to the 4th. I look at 42 and 36, and I note that they're each divisible by 2, they're each divisible by 3, which makes them both divisible by 6. So I'm going to go ahead and start with that 6. Remember we talked about starting with higher factors, then you have less rungs on the ladder. 36 divided by 6 is 6. We bring down our x to the 5th power, y cubed. 42 divided by 6 is 7. We have x, y to the 4th. Then I look for common factors. There's none. 6 and 7 are relatively prime. Therefore, the x's, I look at the variable x. I have 5 of them here, 1 of them here. So I have to look at that smallest power I can only divide by, 1x. So when I have 5 factors of x and I divide by 1 factor of x, it leaves me with 4 factors of x. So x to the 4th, y cubed. If I have a factor of x and divide by a factor of x, I'm left with no x's. So I have y. Now I see that there are still some common variables. The y's are common. I have 3 factors here, 4 factors here, so I can divide by y cubed. So that leaves me with 6x to the 4th here and 7y over here. The bottom rung is relatively prime, so my GCF would be found by multiplying the 6 times the x times the y cubed. Okay. Now, just as he did in the video, we could look just at the numbers. Sometimes that makes it a little easier to see. Okay. Again, we could still divide by 6, get 6 and 7, and there's our GCF. Okay. And I'm going to give you another way of looking at the variables. If we list them out for the first one, like factor the monomial, we would have 5 factors of x and 3 factors of y. So sometimes seeing how many we have will be very helpful. For the second term, monomial term, we have 1 factor of x and 4 factors of y. So when we look at what we have in common, okay, we have 1 factor of x right here, okay, and then we have 1 factor of y, another factor of y, and a third factor of y, all in common. So if I look straight across, what do I have? X times y times y times y, or x, y to the 3rd power. Okay? So circling the common factors or the common prime or the common variables, and then you can see, what did I circle? I circled 1x and 3 y's for each of those terms. Those are what they have in common, nothing else. We have 4 extra x's in the first term. We have 1 extra y, but that's just part of that relatively prime part. It's not a part of our answer. What he talked about in that last video was, since we're talking about factors and we have kind of distinguished between factors and multiples, and factors are those building blocks and the pieces and they are smaller, we want to use the smaller exponent, which would be this one right here, which has an exponent of 1, and the y cubed, which is less than y to the 4th. So multiple ways to do this and look at this to see how to do it.